So in this video, we're going to evaluate the sum of 1 over 2 to the r between r equals 1 up to r equals infinity. Now, there should be a good clue with this question. If you've got an infinity in there, you're probably going to use a sum to infinity formula, and indeed we are. But let's look at why. If we start to list what our terms are, starting with r equals 1, we end up with a half. It's a sum, so we're adding each time. R equals 2, we've got a quarter, r equals 3, 1 over 8, r equals 4, 1 over 16, and so on. The only difference with this problem is we're not stopping at r equals 10 or r equals 100. We're going up to an infinite number of terms, so this carries on. Now, if we look at our expressions here, you should be able to tell that really we have a multiplication each time of a half, so we're really timesing by a half. And if it's a value which stays constant each time, if we're multiplying by a half each time, it's a common ratio, which means that it is a geometric series. And if it's a geometric series, we're summing to infinity, we can use the sum to infinity formula. Well, in order to use the sum to infinity formula, you need to know A, you need to know R. Simple as that. Well, we've already started to list what our terms are. So our first term A is a half, and R, which is our common ratio, which we've already worked out as a half, but you can check this. Say the second term divided by the first term, so a quarter divided by a half, which is a quarter times 2, which is a half. Okay, you can check it with any consecutive pair of terms. So we have our values. So really we want our sum to infinity, which is a reminder, the formula is A over 1 minus R. A is equal to a half. We have 1 minus R, which is also a half, which is a half over a half, and anything over itself like that just gets us 1. Nice and simple. So just to tidy that up then, our sum of 1 over 2 to the r between r equals 1 up to r equals infinity is just equal to 1.